Good afternoon, everyone, and welcome to your subject in CPT 3 Fundamentals of Crop Science. So, last time we discussed the chapter 2 of your subject, which is about crop production, agriculture, and trade. And so, please watch on the video posted so you can review our lesson last time. Now, we are now on Unit 3, which is site characterization for crop production. So this site characterization for crop production involves the different factors that affect the growth of plants. So what do you think are the different factors that influence the growth of crops? So I have here the map of the world, and these are um, classified based on the different um, climatic zones in the tropics, as you can see. So we have here the green one on the photo shows the tropical wet. So the green colors of the different maps of the world are, so as you can see, tropical, including Philippines. You can see here the country Philippines is in green color. So along with, usually the green colors, the tropical region are in the equator side of the globe. Then followed by the tropical wet and dry, which are gray portion, and then the dry semi-arid, which is the brown portion, and the beige color part, the arid, as you can see, that's above. It's actually the division is actually starting from the equator. It's just degrees up and degrees down the equator. So you can see beige or arid regions at the upper portion of the equator, the north and the south pole or of the equator, north of the equator and south of the equator. So whenever I talk about this lesson, I always ask my students that which part of the globe or of the map is Philippines located, and you might be always misinterpret Philippines. Is it north or south of the equator? So as you can see here, it's actually on the north of the equator. So to continue, we also have the moderate, the Mediterranean, which is the yellow-green color, the humid subtropical, which is the orange color, and the marine west coast, which is the color here in represented by aqua green color or aqua blue, and the continental, the humid continental, which is yellow, and the subarctic, which is this one, the purple color, which is way beyond the north of the equator on the north pole. So you can see here the polar or the tundra with the bluish color, the polar region. So it's so cold in here already, and even down the north and the south pole. And the white one is the ice cap already, and the highlands with a gray, white gray, and non-permanent ice represented by bluish light blue color. So those are the different climatic zones in the globe. No, we also have climatic zones in the tropics known as the humid tropics, the subhumid, the semi-arid, the arid and desert areas, and tropical highlands, which are already represented in the figure shown below. So this, as you notice, what is the importance of studying this climatic condition? So you will know that most of the plants thrive best in the tropical highlands because under the equator are the tropical areas wherein the amount of sunshine is substantial enough for the growth of plants. So, in terms of geographical distribution, the 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 tropical, which we belong, actually located between the 23.5 degrees north and south of the equator. And this constitutes 38% of the Earth's surface. So once again, the humid tropics are under a rainy climate with 1,500 to 4,000 millimeter bimodal or unimodal with 8.5 to 12 humid months. So the humid tropics includes tropical rainforest vegetation, which includes the Amazon Basin, Congo Basin, Indonesia, Malaysia, Philippines, Atlantic coast of Central America, and Pacific coast of Colombia, coastal West Africa, and Pacific Islands. It also includes mountain forest vegetation, highlands over 900 meters in Mexico, Guatemala, Costa Rica, Colombia, Ecuador, Peru, Bolivia, Kenya, and Ethiopia. And subhumid tropics involves seasonal climate with a wet to dry tropics with only about 500 to 1,500 millimeter rain, unimodal or bimodal, and with 4.5 to 8.5 humid months. And the subhumid tropic vegetation includes semi-deciduous and deciduous forests. When we say deciduous, these are trees that have fallen when their leaves fall down in the ground, and then they have green shoots again after a while. And plus tall grass, low tree, and acacia tall grass savanna. The subhumid tropics includes the Cerrado and Mato Grosso of Brazil, Llano of Colombia and Venezuela, Pacific coast of Central America and Mexico, Veracruz, Yucatan Peninsula, and Cuba. The subhumid tropics, most of Africa between Sahara and Kalahari except Congo Basin and Guinea coast, most of India, and northern Australia. So those are the countries that belongs to subhumid tropics. The semi-arid tropics is a very dry climate as well, with only 250 to 500 millimeter rain unimodal and 2 to 4.5 humid months. So if you remember earlier, in a tropical area, it has about 2,000 millimeter of rain. But for semi-arid, like the semi-arid tropics vegetation includes the dry steppe, woodland, scrubland steppe, and dry savanna. So that's the only vegetation that you can see in a semi-arid tropics. And the semi-arid tropics countries include the Sahel of Africa, Kalahari, large portion of Australia, parts of central India, northeastern Brazil, northern Venezuela, northern Mexico, Chad, Somalia, and Tanzania. The arid desert, if the semi-arid only has 250 to 500 millimeter of rain, but the arid desert can even have 0 to 500 millimeter unimodal rainfall with 0 to 2 humid months. And the only vegetation that thrives in the arid desert are the thorn and succulent shrub with bare vegetation. So imagine, what you can see in an arid desert. This includes the Sahara, the Somalia, even Australia have a desert too. The Southeast Africa, narrow coastal strip of Peru and Chile. So what is the agriculture in a typical tropical country like Philippines? These are characterized by the following. We have subsistence oriented, low productivity, high production risk, uncertainty, and even until now, kaingin system still prevails. If you have heard kaingin system before on your introduction to agriculture, you will learn that kaingin is just like burning the leaves, the burning the trees and the bushes, the grasses down in order to plant crops. And we all know as for now that burning and can emit carbon dioxide, which carbon monoxide, and which became greenhouse gases that can cause global warming. So it's not really good, no, for now. So why subsistence oriented? Because most of our farmers are really poor, no, and they only subsist, no. It's the income that they had is just to subsist, or to not really, not even really to sustain, but just even to live, no, basically living. And low productive because these are affected not only by different factors like environment, fertility of the soil, but also mostly because of catastrophes like floods and storms. So that's characterize our agriculture here. And high production risk because sometimes when the crops fail, so we can't do anything about it but lose our investment. And uncertainty because of the weather condition. And low productivity is caused by loss of fertility due to nature of the soil and heavy rainfall, as I have said, flood, heavy soil loss, nutrients leaching, rapid growth of weeds. That's if you go to other countries like the savanna area, the the weeds and the bushes don't even grow tall, no. It's just a so very small weeds, no. But here in a tropical country like Philippines, weeds are very, very good competitor of crops. They are even notorious, no. And multiplication of pests and diseases, yes, are also high. The more that the plants grow, the more the pests and diseases are. And as what I have said, the kaingin system prevails because most of our indigenous farmers just do this as their culture. They just go from burn one place and then go to another place without even putting back all the nutrients, no, in the soil. So let's talk about the centers of origins of the different crop productions. As you can see on the figure here, we have barley and apple, apricot, soybean, millet, wheat. We have sugar beet, and millet, and eggplant, which are actually sugar beet, olive, cabbage, coffee, chickpea, eggplant, and sugarcane and rice. Actually, mostly comes from or rooted or originated on the Mediterranean, no, where civilization started, and even in it's throughout the Asia. While you can see here corn, chili pepper, peanut, potato, and lima bean originated in somewhere in Europe and America. In the continent of South America. So factors that affect crop growth includes, this is the answer to the question that I have asked you in the first slide. So can be divided into technical, which are natural, like physical, climate, soil, and biological, like pest diseases, weeds, and cropping pattern. And human elements, they can be exogenous factors, meaning outside, and endogenous factors, meaning inside. So let's start with physical factors like climate. So this includes temperature range, humidity, rainfall pattern, water system and management, solarization, and wind. For the temperature range, usually the temperature range in the highlands, which range from 13.2 to 24.6 degrees Celsius, like in Baguio, with an elevation of 1,200 meter above sea level. These are the temperature range that are characterized in highlands, like Baguio, and the temperature range from 23 to 30 degrees Celsius are in lowlands like Laguna with 22 meter above sea level elevation. And as a golden rule, 100 meter up will decrease the temperature by 0.6 degrees Celsius. So monthly average temperature is lowest in January with 22.5 degrees Celsius and highest in May with 28.2 degrees Celsius. So, three cardinal temperature actually affecting plant processes includes the minimum temperature, the optimum temperature, and the maximum temperature. When we say minimum temperature is below which velocity of reaction becomes zero. So, below which, like when we say the correct temperature for corn is 38 based on the table. So below 38 or below the minimum will become destructive to plants already. And when we say optimum temperature, it's the reaction velocities at maximum. So it's the best temperature for the growth of corn, which is 38 degrees Celsius. And the maximum temperature is the above which reaction velocity becomes zero. It's when it's the maximum level of temperature that the plants can tolerate to grow. So, this table was showing the threshold high temperature for some crops. So, when we say these are the threshold temperature, like for wheat, 26 degrees Celsius, and the growth stage is pulse anthesis. So, this is the threshold temperature, the maximum temperature for wheat. For corn is 38 degrees Celsius during grain filling, and for cotton 45 degrees Celsius about high. No, this is for reproductive. And pearl, millet 35 degrees Celsius during seedling stage, tomato 30 degrees Celsius during emergence, brassicas 29 degrees Celsius during flowering, and cool season pulses 25 during flowering, groundnut 34 during pollen production, cowpea 41, which is somewhat high for flowering stage, and rice 34 degrees Celsius for grain yield. So much about temperature range. The east and the west facing slope. So when you have a slope, those are the east and the west are receives light for a few hours each day, while those in the north facing slope do not receive sun but bright enough to grow plants. So they are 40 days longer than flat side in terms of growth and development. So when you have a slope, usually plants that are in the east and the west facing slope are the ones with enough light, no? And north facing slope have few lights. So crops are actually classified based on temperature requirement. They can be cool season or warm season crops, tropical or subtropical. So cool season crops includes coal crabs. We call them coal crabs when they are horticulturally classified, like the cabbage, broccoli, cauliflower, peas, potato, shasta daisy, carnation tea, and etc. And warm season like rice, banana, and tropical coconut, pineapple, and subtropical citrus. So this is based on their climate or temperature requirement. So, have you heard about the word vernalization before? It's the low temperature exposure from 5 to 10 degrees Celsius, which is like almost freezing. So, these are the requirement of crops for flowering, crop maturation, and germination, and also for lettuce germination. So, this process is being used for the flowering in aster, carrot, cabbage, celery, onion, cauliflower, beets, parsley, and more. So it's also used as devernalization in onion. When we say devernalization, it's the opposite of vernalization. So the seeds of this lettuce, for instance, are subjected to 5 to 10 degrees Celsius for about 24 hours or more so that they can have better germination. And if they are subjected into this, then for cabbage, for instance, carrot, and aster, they will flower better. So what is growing degree days? It's a match or GDD. It's for maturity determination of a number of crops and for suitability of certain crops to a particular environment. So this is used for predicting risks associated with crops in specific locales, for finding effect of sowing date on the rate of development. So you can compute this growing degree days. This is actually the measurement of the departure of the daily mean temperature above minimum threshold temperature for a plant. So you need to know the base temperature for corn. For instance, it's 10 degrees Celsius, for soybean 12.8. So adding base temperature with the difference between base temperature and average daily temperature, this is how you measure the GDD. So for mango, the which is 17.9 degrees Celsius is equal to 1000 degree days required for maturation. So that's how you compute the GDD. So actually, going degree days is just a concept that is being used for measuring the growth of plants using technology. So you have actually what do you call that, a parameter, a growth parameter when you use bioinformatics or technology in measuring growth of plants or predicting the growth of plants. So another factor is the relative humidity or RH. It is the amount of moisture in the atmosphere relative to the saturation point at a given temperature. So in Philippines, it has 82% relative humidity, and this is because to the evaporation from seas, moist air streams, and high rainfall. And this affect plant growth, pest and disease incidence, and post-harvest handling. So plant growth is better together with pest disease incidence is also high, and when you have high RH, post-harvest handling can be also good or bad, no? So same as that, you have enough moisture to preserve the crops, the commodities, but then pest and disease incidence is also high. Another factor is relative humidity. It's for the dry atmosphere. For the dry atmosphere, yes, again, the same factor, relative humidity. For dry atmosphere, the transpirational loss of waters of grass will result wilting and shrinkage. And this will also cause irrigation requirement for plants because of evapotranspiration. That's during dry atmosphere, but for high humidity, disease control is also difficult. Like for grain drying, mold and aflatoxin is a fungal toxin will attack. And also in fresh fruits, they can be stored longer. So this is what I have just discussed. And for rainfall pattern, we have the bimodal, which is close. When we are close to the equator, usually rainfall pattern is bimodal, meaning they have two modes. And some distance to the equator or farther than equator, north and south, have monomodal rainfall pattern. So primary source of water without irrigation supplies 80% of the cropland in the world. So mostly rain-fed lang talaga sa whole world. Mostly 80% of the world of cropland, especially here in Philippines. It affects soil workability, crop growth, and development, and the maturing crop. So we typically in the Philippines, we just depend on rainfall. That's why in Israel or in other countries where rainfall is very limited, they were the one actually who discovered irrigation system, no? Drip irrigation because of their limited rainfall. So what is the influence of water on plants? So water is very important as it came from rain. It is a reactant in many biological reactions like hydrolysis. We all know hydrolysis is one of the processes involved in plant growth, and water enters into the structure of many biological molecules such as carbohydrates and serve as a medium for transport of nutrients from the soil and photosynthesize. So imagine that nutrients from the soil cannot be taken by plants without water itself. And even the products of photosynthesis or photosynthase or the sucrose and carbohydrates cannot be transported without water. So they help regulate favorable plant temperature during transpiration. So plants are actually classified based on moisture need. So they are known as the xerophytes. These are plants in arid environments like the cactus, and hydrophytes like the aquatic plants, like the water lilies, and mesophytes for the land plants. Most of the economically grown crops like corn, potatoes, and more. So in the Philippines as well, we have the so-called modified Corones classification. So the climate in the Philippines is divided into 4 types. Although nowadays, because of climate change, this may be unpredictable. Climate may change anytime, anywhere. So for the type 1, which is in the color red, are the distinct wet and dry season, no? From Luzon areas to Visayas areas, they have wet and dry season. But for type 2, which is the yellow one, on the right side of the countries, there is no dry season, all raining. But the type 3, which is the green in the middle portion from Luzon, Visayas to Mindanao, are actually no wet season, all dry. And also the type 4, which are mostly on the right portion of the country, from Luzon, Visayas, and Mindanao. It's where evenly distributed rainfall. So this includes Mindanao, Davao, Tagum, as you can see on the color range. So once again, for type 1, the dry and wet, the maximum rainfall is between June to September, with only 3 to 6 months dry season, less than 50 millimeter rainfall. So for type 1 or dry and wet season, this includes Ilocos region, west of Mountain Province, Nueva Ecija, Central Luzon, Manila, Cavite, Laguna, Batangas, Occidental Mindoro, south of Antique, Iloilo, northeast of Palawan, and south of Negros. So for type 2, no dry season. It has a maximum rainfall in December to January, and this includes Kalinga, Apayao, northwestern Cagayan, western Quezon, Polillo, Bicol region, northeast Samar, southern Leyte, Surigao, Agusan, and Misamis Occidental. And for the type 3, it has short dry season and no rainy period, with about 1 to 3 months dry. So this includes northeastern Ilocos, Norte, Kalinga, Apayao, Cagayan, Mountain Province, west of Nueva Vizcaya, Bulacan, east of Laguna, and Batangas. And the type 3, again, no rainy period, includes Oriental Mindoro, Romblon, Marindoque, Aklan, Capiz, north of Antique and Iloilo, Negros Occidental, east of Negros Oriental, and Siquijor. So note that even in one place, there can be different type of climate. So also Zamboanga del Sur, Basilan, Lanao del Sur, Bukidnon, Misamis Oriental, west of Agusan del Sur, north Cotabato, and east Maguindanao. And for type 4, where rainfall is evenly distributed throughout the year, we have Batanes Province, northeastern Luzon, western Camarines, norte Camarines Sur, Albay, eastern Mindoro, Marinduque, western Leyte, northern Negros, and most of central, eastern, and southern Mindanao. So mostly. So crops grown based on rainfall pattern. Most crops and most fruits are best grown in type 4, where rainfall is evenly distributed throughout the rain. While there are also some crops which are most economically grown with continuous dry season with at least 4 months dry without rain. So this include mango, tamarind, cashew, and onion. So these are the factors that affecting rainfall. We have topography, air circulation, high relative humidity, sufficient low temperature, which is below condensation point, condensation nuclei, and sufficient low pressure. So why this drought happens? It's just the insufficiency of rainfall or moisture which affect plant growth. So this can be classified into two, absolute or partial. It's absolute when it constitutes 29 consecutive days without rainfall with at least 0.25 millimeter. But it's only partial if it's only 15 consecutive days without rainfall of at least 0.25 millimeter. So mostly, under drought, absolute drought definitely can kill or dry out the plants. And with partial drought, most of the plants can still thrive, but the growth and the yield is already affected. For water system or management, irrigation is important in improving yield and quality of crops, and it permits the use of production improvement factors in farming and makes more effective use of water holding capacity of soil to grow crops during dry season. So irrigation is very important. This includes drainage for waterlogged soils, diversion, harvest, and storage of water. So it is very important to have a water conservation or management practices, proving effective in stabilizing and improving crop yield. So it is also important that you maintain moisture or water level in your plants. So another factor is the solar radiation. It's the most important factor that affect crop yield. And it has three aspects of light. We call it the intensity, which is measured in foot candles or lux, and the duration or day length, which are the hours from sunrise to sunset, and wavelength measured in angstrom or nanometers. So let's talk about light intensity. It's only about 47% of sun's energy which can reach the Earth's surface. And we call PAR or photosynthetically active radiation used by plants to fix carbon dioxide during photosynthesis. And albedo is the amount reflected determines how fast and the degree the surface is heated. Water has a high albedo. So like the ice, the snow, and the clouds. So 40 to 90%, it has 40 to 90% albedo or the light reflected. While the forest and grasslands has only 5 to 30%. So the amount of light should be above light compensation point before plants can grow. So plants are therefore classified based on light intensity. So in terms of effect to plants, also they can be photoenergetic. So it means for photosynthesis, and photocybernetic when it's for plant development. Less light during wet season and at highlands is positively correlated with grain yield. So with high increase of 100 Langley per day is equivalent to higher yield of 1.1 tons per hectare. So the more light, so as long as it reaches the light compensation point, it's very beneficial to the yield. So as I have said, light in terms of light intensity, the plants are classified as heliophytes, or they called as sun-loving plants. They are light saturated about 5,000 feet candles. This include corn, the upland rice, the cowpea, peanuts, sweet potato, watermelon, papaya, banana, citrus, and various vegetables. And they can be medium if they are sunny, at least 4 hours a day, for onion, garlic, Chinese, chives, asparagus, carrots, celery, cabbage, Chinese cabbage, cauliflower, broccoli, petchay, mustard, lettuce, spinach, and gabi. And also cyophytes if they are shade loving, and the light saturated about 500 feet candles only. And examples are the black pepper, cacao, coffee, lanzones, mangosteen, durian, ginger, and vanilla. And they grow and yield more if they are under shade. So next is day length. It's the hours from sunrise to sunset. So the Philippines is under the tropical countries, which is in the north of the equator. So we have 12 hours definitely all year round throughout the year. This changes during the year in a location. So based on day length, the plant's response in flowering to day length is called photoperiodism. And in terms of germination response to day length is called photoblastism. So what is photoperiodism? So these are the response in flowering as affected by day length. So plants are classified based on photoperiodism. They can be day neutral plants, short day plants, or long day plants. These are day neutral plants if flowering not regulated by day length, like the kidney bean. So no matter how the length of the day is, they're not affected. But for short day plants, these are the plants that flower in short days with below critical day length, like the chrysanthemum, pineapple, and coffee. So they want short day, no, more night. And lastly, the long day plants. These are plants that flower in long days above critical day length. So this include wheat and aster. So they like to flower when the day is longer. So in terms of photoblastism, the germination effect, the plants are classified as positively photoblastic or negatively photoblastic. So positively photoblastic, when germination is uninfluenced by light, like the grasses, the lettuce, the carrot, and mustard. And they are negatively photoblastic if germination is inhibited by light, like melon, pumpkin, and cucumber. So another one is the wavelength. So light had a wide range of electromagnetic radiation. And the biological window of light range from 300 to 1000 nanometer. That can cause biological effects or growth and development, not only to plants but also to all living organisms. So we call them, as you can see, this is the wavelength of light, no? You can see on the photo, no, the different we start with short waves. This is the waves that actually use in television and radios, no, the AM and the FM, and the radar, followed by the infrared rays, and the shorter wavelengths, the ultraviolet rays, X-rays, and gamma rays, which are more distracted. The more shorter and the distracted. But in between the UV and the infrared rays is the visible light, which include the colors violet, blue, green, yellow, orange, and red, ranging from 400 to 700 nanometers. So this also corresponds to the photosynthetic photon flux, or known as PPF. So what are the effects of this visible light wavelength? The red and blue, so these are definitely from the sun rays. The red and blue are effective in photosynthesis. The far red and red effective in photoperiodism, or the flowering, and the far red 700 to 800 nanometer influences morphogenesis. And the UV light causes damage on plants already, and even humans now, and all living things. That's why we also use UV light for disinfection. Another factor is the wind. So 3/4 of the Philippines is under tropical cyclone with 63 to over 118 km per hour wind. And 31 to 41% most frequently hit in northern Luzon, Batanes, northern Samar, Sorsogon, and Masbate. Typhoons usually occur from July to September, but anytime can change with the climate change. With a wind speed of 100 km per hour, can cause already complete destruction, for instance, in banana. While Mindanao have been based on historically a typhoon free, but now there has been, especially for flood, no, has one of the different the different factors that can distract the crop production in Mindanao. Now, what are the effects of strong winds? This can cause crop lodging, subsequently yield reduction, green shattering, affects transpiration as well, and straight upright curve growth to plants. It can also cause sterility due to pollen loss and reduce carbon dioxide levels, especially in enclosed spaces. And the disease spores dispersal is faster with stronger winds. So the air circulation in the atmosphere results actually from the sun's radiation falling more directly on the Earth's tropical regions than polar regions. So most of the sun rays are on the tropical region than polar region. And the greater the radiation input, the greater also the convective influence of and the higher the wind speed. So the radiation modifies wind movement and wind modifies temperature. So come along with radiation is also higher wind speed. So what are the physical factors? This includes soil. Geography, as it covers boundaries, numbers of cities, municipalities, and barangays. Topography and elevation range, the land size, and soil properties. So when we speak of geography, the bigger geographical area shows more farmers take hold of bigger land holdings. In a large farms, planted usually with one or few crops, while small farms have more diversified. And this actually is fascinating true. And in nearby cities and outlets will lead to intensive production of cash crops, vegetables, fruit trees, and cereals, legumes. So what is the effect of topography? This is related to the terrain of the land, and this affects water availability. For drainage and runoff is faster in steep slopes and usually leach and water lag in flat topography. And this influences soil temperature as well. So the temperature is lower by 1 degree Celsius for each 300 meter elevation for the first 10 to 15 kilometer of altitude. So the higher the elevation, the lower also by 1 degree Celsius is the soil temperature. And we all know that the high temperature will influence crop growth. So topography also affects amount of solar radiation. Facing directly to the sunbeam receives higher illumination and light intensity. 500-meter increases elevation or higher elevation and lower temperature by 3 degrees Celsius. So the cold season crops are adapted to this condition. Land size can also be another factor. This influences the type and arrangement of grass, spatial or temporal, and the cropping pattern. So with big areas or lands, they vary in cropping patterns with wide range of feasible cropping system. Stocking of more livestock with grazing areas, for example, while in small areas is only limited, having shorter turnover time, and these are only best for annual or cash crops. So soil properties is another factor. We have properties like texture and structure. So when we say soil texture, this is the smoothness or grittiness of soil, which depends on the proportion of variously sized particles. Soil structure refers to a function of the arrangement of the soil particles and the space between them. These are related to the soil workability and water holding capacity. So soil are actually classified based on texture, like sand, silt, loam, clay, etc. So when we say sand, these have coarse texture with 0.10 to 2 millimeter diameter particles, and these are very good, excellent aeration and drainage. with low cation exchange, fast permeability by water, low water or nutrient holding capacity, and easy tillage and erodibility by water. For silt loam, it has a medium texture. That's why it's best for germination and growth of crops. With 0.00 to 2.05 millimeter diameter particles, good for aeration and drainage, and with medium cation exchange and moderate permeability water, moderate water nutrient holding capacity, and moderate tillage and erodibility by water. And for the clay, it has a very fine texture with less than 0.002 millimeter diameter particles, but it has poor aeration and drainage, high cation exchange, slow permeability by water, high water nutrient holding capacity, and therefore difficult tillage and erodibility by water. So aside from texture, we also have soil structure. This will improve through tillage and application of organic matter anyway. So you can see on the photo here, crumb or the structure can be crumb or granular as shown, or platy as shown in the photo, or blocky, or prismatic, or columnar. Although when you till the land or when you plow the land, the structure usually changes. But then, the best soil structure is the granular, especially for germination. So the soil depth as well is very important. It's the distance from the soil surface to the lower layers of soil profile which obstruct root growth and proliferation. The topsoil is where the majority of nutrients are obtained, while the subsoil is the storage region for water and determines depth of plowing. So as you can see on the figure here, the soil structure have horizons, the O horizons with the leaf litter organic material, the A horizon, which as you can see, that corresponds to the levels on the figure. It's the plow zone, and it's also rich in organic matter. Well, the B horizon is the zone of accumulation. It's where the secondary roots with root hairs are located. So it's where the nutrients are absorbed. And the C horizon below is the withering soil with little organic material alive. And the R horizons are the unwithered parent material, and it's so deep already. So soil pH is another factor, especially in terms of nutrient availability. The degree of acidity and alkalinity of the soil is known as the soil pH. It ranges from 1 to 4, and 7 is neutral, or the number of hydrogen ions is equal to the number of OH. So below 7 is acidic, and above 7 is cold alkaline. So in Philippines, our pH range from 5.5 to 6.5 pH, which actually is favorable for the growth of crops, and it affects solubility and availability of nutrients and affects the activities also of soil organism, like the microbes that very important or also alters the growth of plants. So in terms of soil pH, if it's below 5, the aluminum, the iron, and the manganese become soluble and toxic. And below 5.5, which is acidic, the molybdenum, the zinc, potassium, and sulfur is deficient already. But above 7.5, with its alkaline, aluminum, zinc, iron, and salinity becomes toxic. And above 8, calcium phosphate is already unavailable. And above 8.5, which already alkaline, the sodium increases, salinity, zinc, and iron is deficient. pH can be increased by liming or reduced by adding sulfur or fertilizer with residual activity like the ammonium sulfate. So as you can see here on the figure, soil, acidity, and desirable ranges for garden crops. So ranges from 5.5 to 8.5, where most shrubs, trees, and turf grass, asparagus, spinach, okra, bluegrass, junipers, clover, melons, potatoes, camellias, tobacco, pineapple, centipede, turf. And while blueberries, azaleas, gardeners, and hydrangeas can thrive below the on the acidic portion. So you can see also on the next figure the nutrient availability according to pH. So when we say nitrogen, it's very available on the neutral, no? From 5.5 to 7.5. So further than that, it's become acidic or basic. It's not already available. But for phosphorus, as you can see, it's available from the range of 5.5 to 6.5, and again to 8 and above. While potassium, it's available when the pH is neutral to basic, as well as sulfur. But for calcium, it's only from the range of 6 to 8. And for magnesium also, and for iron, it's high when it's acidic, and also for manganese, and also for boron, it's despite of the acidity, its level is almost the same. And for copper and zinc as well. And for molybdenum, it's higher when the soil is basic. So what are the different soils of the tropics? I hope you have heard this following classification. We have the so-called oxysoils. These are highly weathered soils containing high amounts of oxides of iron and aluminum. Oxysoils are usually red soils. We also have alphy-soils. These are soils formed in well-drained upland areas of coarse to medium surface texture with a clayey horizon of more than 50% base saturation. And we also have ulti-soils with highly leach acid soil with less than 50% base saturation found in humid tropical and subtropical areas. And aridisols, soils of arid and dry regions with limited change in the parent material because of the low rainfall. So these are the classification of soils in the tropics. This can be oxysoils, alphysoils, ultisoils, and aridisoils. So next are the biological factors. We have number 1 is the pests and diseases. Second, weed density and frequency, and third, the cropping pattern. The yearly sequence and spatial arrangement of grants and fallow on a given area. So these are the biological factors that affect the growth of plants. So human elements can be exogenous or endogenous. Exogenous includes the community structure, norms, and beliefs. So crops grown reflect the need of community dictated by the food habits and tastes of people. Definitely, Asian countries have rice, while Western have potatoes. Infrastructure, for small farms have poor roads, inefficient transportation channels, and poor market condition. And third is marketing practices or facilities. Untimely transport of produce increases post-harvest losses and will deprive optimum market price benefit. And lack of adequate storage facilities to maintain quality and storability of products. And lastly, population density. The increase in population pressures reduces time that soil can rest in the fallow period and accelerates erosion and decline productivity. Therefore, higher population overuse of soil. Cultivation and even steep slopes, siltation can cause siltation of riverbeds and flash floods in lower plains. And for the endogenous factors, we have land, labor, and capital. So, very important, we have a land. These are constrained in all developing countries like Philippines, where farm sizes are small with an average of 2 hectares. So there's need to produce crops with intensive cropping, and without proper soil fertility program can result to marginalized from productivity. Small farmers are left behind by big corporate farmers. So these are the economics of scale in production. And labor is another very important. Reduced labor availability can it's very problem, no, in some areas, but not so much in Philippines. Labor peaks for planting and harvesting. Insufficient capital to pay hard labor is common problem, which results in delay in farming operation. And lastly, capital, the lack of money, collateral, and if also with the high interest rates of loans also. And lastly, the social, economic, and political issues. This includes the climate change, which we have discussed earlier, the Republic Act 9729, and Biofuel Act, Republic Act 9367, the Sustainable Agriculture, the Organic Act, Republic Act 10068, the High Value Crops, Republic Act 7900, and the Comprehensive Agrarian Reform Law under Republic Act 6657, or the establishment of big corporate farm is illegal, and retention limit is only 5 hectares of land per family plus 3 hectares for each eligible year. So imagine all these factors that affect crop production. So thank you very much for listening, and I will wait for your questions during our next meeting.